Alrighty, so I'm going to go through these two questions like you asked. So after this, let me know if you have any problems or there's something that you don't understand. So it says construct two similar triangles, one with the measurements of 5, 12, and 13. So let's just focus on that one for right now, okay? So triangle, oops, 5, 12, 13. Okay, that's fine. We don't know what kind of triangle this is. We don't know the angles. So that's what it is. So because they're similar triangles, we know with similar triangles, the angles are the same, right? So when it says explain your steps in constructing the triangles, that's more for you trying to to tell me, well, they're similar, meaning the angles are going to be the same. It's just the lengths are being different. Okay, so it is kind of worded funny. Now looking at it again, I do agree. So I'm not too worried about that part. I'm just more worried about the calculating of the next triangle. So construct two similar triangles. Sorry, explain your steps in constructing them. The second triangle has a ratio of proportional sides of 3/2. 3/2 is also 1.5. Okay, so actually what we're going to be doing is, so this triangle is going to be 1.5 times the size of this triangle here, but the angles are still the exact same. So what I'm going to do is just take each triangle, each side, and multiply it by 1.5. 1.5 times 1.5. Because it's three halves, or 1.5 times the side. So 5 times 1.5 is 7.5. 18. And 19.5. Okay. Determine the measurements of the unknown side. Done. Explain the process used in solving the unknown sides. Well, because we know that it's 1.5. Because we know it's 1.5 times bigger, all we have to do is say, well, we know the angles are going to stay the same. We just need to multiply those sides. And that's it. So not as much actually to it as it seems that there's going to be. You know what I might do? I think I'm going to make this question, it says it's out of 6. I think I might make it actually only out of 4. Judging, because looking at it again, you're right, it is a little confusing. So don't worry too much about that one. But yeah, okay. And then the other one. So while on a train journey through northern Ontario, a passenger was curious about the height of the train. At one of the stops, she noticed that a passenger was standing next to the train. She knew his height and knew she could measure the length of his shadow and that of the train. She must be really bored on this train. The passenger was 1.5 meters tall, so here's the guy. Yeah, he's sitting down, I guess. He's 1.8 meters. And he is a shadow. Oh, he can't be sitting down. He's standing. He is a shadow. That is 0.6 meters long. Okay, we're assuming it's going to be a right perfect. Well, we don't actually need it to be exactly a right angle triangle. But this would be his shadow. And this is him, right? I guess it would make more sense if it goes like this. Okay, hopefully you can see that. The shadow of the train was 2.4 meters long. So again, we're going to draw another triangle. But in this case, this is the shadow of the train. So because we're dealing with similar triangles, they're all going to be ratios of each other, right? So from here to here is going to be the same increase from 1.8 to the height of the train. So this is my train right here. I can't draw a train. And that's the train shadow. So we can set up a ratio. And so when it says the principles of similar triangles, it just means if the one length, let's say if the one length is going to double, the other lengths of the triangle are going to double, right? Because they're similar triangles. They're not the exact same, like congruent. So the angles, again, are going to be the same. For the angles to stay the same, they all have to grow at the same proportion, or it won't be a similar triangle. So what I do is I set it up. 1.8 goes with this is the same triangle. Okay, so these two are within the same triangle. This is the same, would be our height. This is the same units. And this would be our shadows. I'm just gonna write shad. So that means, since this has to be, this next section here has to be from the same triangle as well, we have to set it up the same way. So the height of the train, we don't know, and the shadow is 2.4. So what I do, I did this thing, it's called like the fish method. You start with the number, well, I guess you're academic, but it doesn't matter. You start with the number that goes with the unknown letter. So my 2.4, I go up, down, and across. So when you go up, you multiply, and then you divide. So it's 2.4 times 1.8 divided by 0.6. Divided by 0.6. And it's 7.2. Okay, so another way you can think of it as, for us to get from 0.6 to 2.4, if I divide that, 2.4 divided by 0.6, that's 4. It's a perfect 4. So that means the train is 4 times the height of the guy. Well, if I do 1.8 times 4, I know you can't see my calculations. 7.2. Okay, let me know if that helps. If not, let me know. And I can find something else that we can go over together. We can do like a WebEx thingy if we want to talk face-to-face kind of, you know what I mean. Okay, I hope this helps.